Hello, how are you?
I'm doing good.
Yay. Happy Monday. Hello, happy Monday to everyone.
Hello.
I know everybody loves Monday. Did everybody get signed up for a final time? I didn't even look yet. Good. I'm running a little bit behind I'm going to be grading like a maniac this afternoon. Or this evening, I should say. Because I know you got a lot of things that need to be graded. Did you like the fraction Jamboard? Yeah. Hannah did. Nobody else did. I'm not sure McKenna did. McKenna, did you like that fraction Jamboard?
No, Maddie and I actually met up in person for the first time, so I got to meet her. That was fun. But yeah, we worked on that for like 4 hours. And
Okay, that might be a little excessive. Maybe email me after an hour and see if I answer. So which question were you stuck on mostly?
Honestly, like all of them.
Okay,
I think the first one we were fine, like that was pretty easy, but I think I don't know, her and I kind of overthink a lot when we work together because we feel like we need to do more than what's like it's asking for. So that's probably what happened, but I wrote a little comment with our submission if you saw that.
Yes, I did.
Yeah.
So it was funny because I met with Bethel and Sunita this morning, and they were really struggling on some things. And we actually read the directions again. And then we magically knew how to do the problems. It's interesting how sometimes we just overlook the directions and decide we know better how to do it than if the directions actually tell us how to do it. And I just experienced that as well in my class right before this. So it's not just fractions. It's not just, elementary school. It's not just college. It is students in general tend to overlook certain things. And as teachers, if we could figure out why, we would change it because we cannot figure out why. So we keep saying the same things and we try to add things and it's very interesting. So, but we'll talk about it today for sure. And I think if you relook at it, you would be like, oh, okay, maybe we were tired or, whatever was happening there. Anyone else? We were talking about the fraction Jamboard activity. The other thing is, I hope when you looked at this week's assignments, you didn't start crying, because boy, did it look like a lot, but it's really not. And we'll talk about what that means in just a minute. I'll show you first, because I think some of you are having a panic attack. Like, I see it on your faces already. You're like, what is this woman thinking? She is insane. I mean, that may be true, but it has nothing to do with the assignments that I did this week. So we'll talk about that once everybody gets here. We're only missing 2 more, so we're almost there.
Are we gonna go over like some more of the mixed numbers? Because I remember how to make them improper. I just can't remember how to make them when they add up together that they're even more improper, if that makes sense. Like with the whole
Sorry to interrupt. On the more videos, it helps a lot, and it explains
it only
each
gave
one.
me it only gave me the one video though with ones with common denominators, but then when they had some with different denominators, which I know how to make the same, but then when I added them up, the numerator was more. And I'm like, okay, how do I thought I knew how to incorporate it, and I would just add another whole and then make the numerator and denominator like, I guess, less. It's hard to explain, but it's not working.
Same. I had to go and Google it. Like, I found a video on Khan Academy that explained that, and I was able to do the problem with the mixed numbers.
Okay. Sometimes
Okay,
the videos
yeah.
on the internet confuse me, and Roxanne's don't.
Yeah, I would agree. I'm not a big fan of the Googling strategy. I'm a big fan of, making sure you get the right info. So Alyssa, did you write one of those questions down?
I have all 4 that I'm having
Okay.
trouble with.
Just give me one and let's
Okay.
work our way through one of them. Let me find a blank.
Can I give you
area.
one easy one and then one hard one, like one with
Uh,
a common denominator?
Well, don't give me an easy one. If you know how to do an easy one, that sounds silly.
I don't know how to
Right.
do it because the numerator is more than the denominator. But I guess if I figure this out, I'll be able to figure that one. Okay.
Okay.
So
Just give me one that you want me to do. How's that?
okay. 4 5/6 plus 2 2/3.
All right.
And you're not sharing your screen.
Thank you. I appreciate you saying that, because the whole time I would have thought I was.
I know.
Yeah, because I'm really good at, because Zoom is new to me. I've never been on it before. I'm just kidding. I'm on it every single day, right? Okay. So here we go.
Oh, I erased my word.
So 4 5/6 plus 2 2/3. Yes? Okay.
Okay.
So this is how I would normally do it, is like this: 4 5/6 plus 2 2/3, because I would say, oh, I can add 4 and 2, that's 6.
Yes.
So now I just need to worry about this fraction part. And if I drew a picture of it, if I had 5/6, there's 5/6, right? And then if I have 2/3, that's 2/3, right?
Yes.
So if I picture it visually, I'm like, ooh, just like we were having our problem in our class the other day with our pattern blocks, these are not the same color, right? Because our pieces are not the same size. So I'm going to make them the same size. I'm going to divide my 2/3 into 6. And I'm going to say, I know 2/3 is 4/6, right?
Yes.
We all agree with that. So I'm going to rewrite this fraction. I'm going to leave the 5/6 alone. I'm going to change this to 4/6, which you should be able to see from my picture why it is 4/6, right? Or algorithmically, if that's how you want to do it. Now I can add these because now they're the same size, right? Or the same color pieces. So now I can add them together and I get 6 9/6, which is correct. It's not the final answer, and more will count you wrong, but it is an accurate description of the answer. Yes.
Yes.
I mean, it's true. Any teacher that you turn it into will look at you cross-eyed and say, you're not done yet, right? But that is the right answer. Yes. But there's a couple problems with it. One problem is there's a common factor, numerator to denominator. They share a 3.
Yes.
Right? So that's one of the issues. The other issue is this together is a mixed number, a whole number part and a fraction part. But if I just look at this 9/6, this 9/6 is improper, meaning it's larger than 1. So I have to fix that somehow. So I can't have an improper fraction and a mixed number together. So I'm just going to look at this part right here, 9/6. 9/6 looks like what, right? Well, if I do 9/6, here's my picture right here, by the way.
Yes.
So I could take this piece right here and color this in. So I have one whole. Do you agree with that?
Yes.
And then I have 1, 2, 3 more pieces left,
Yes.
right? And which is 3 out of 6 pieces left, which is really 1 1/2. Do you
Yeah.
agree?
Yes.
Okay, so now I already had 6. Now I have 1 1/2. So altogether I have 7 1/2.
Okay. So I had 7 3/6. So they want me to go down one more, essentially.
Yep, they want it in simplified form.
They didn't say that.
Are you sure?
Maybe.
I mean, tell me if they didn't. I'll change the question
I was
because
just on it, but I don't know if it says simplify. I think it just has the numbers on it, but it makes sense to do the 1/2. And then I have one more. Can I do one more?
maybe if it's quick, I'm ready.
Okay. 5 minus 1/6 minus 2 5/6.
All right. So what's the problem?
Essentially, it's a whole number, so it discombobulates me, and then there's a fraction. So I don't know where to, I forgot where to start.
Okay, well, order of operations would say go left to right, but
Yes.
I would look at this part. What is this all together? I'm subtracting off 1/6, but I'm also subtracting off 2 5/6. So I'm really subtracting off
6,
2 6/6, right?
uh-huh,
Which what is 2 6/6 the same as?
3.
3. So this is really 5 minus 3.
Oh,
And my answer is really 2.
okay. Well, that was easy.
Now, you could make your life a lot more complicated than that, right?
Yes.
And
'cause I
do it
thought-
left to right, which is fine. You can totally do it.
Yeah.
If you do 5 minus 1/6, I would say, okay, I can't take 1/6 away from nothing here because I don't have any fractional part. So, but I can make a trade. If I take one whole away from here, if I regroup one whole, it's going to be 6/6, right?
Yeah.
So then I'm going to say that's 4 5/6 is my answer. Then I take that 4 5/6 minus, what was it, 2 5/6,
Which is still going to leave you 2.
and I still get 2, no matter which way I do it.
The first way was much easier.
Yeah.
Okay.
So it's just thinking. It's that pesky thinking part.
Yes. Okay. Thank you.
Yeah. Okay. We were talking about the fraction Jamboard, and Bethel and Sunita, tell me if I'm incorrect in this interpretation. You guys were frustrated and were struggling with it. And when we revisited it, what did you realize was your major downfall? What was really keeping you from doing it?
We were reading
Didn't-
tired.
Yeah, we did it super late and we weren't reading the directions.
Yeah, seriously, we're not making it up. They were literally not reading the directions. And the directions were just saying, like, follow along with what David and Vanessa were doing and show it on the number line, right? And if you did that, David and Vanessa were very clear on what they were doing. You just had to follow along. I'm not saying it was easy, but I'm saying it's definitely harder when you don't follow the directions, right?
Yeah,
Okay.
we were like trying to add them all together, then subtract them, and then make a new number line.
Yeah, weird how those directions make a difference. Okay. So, there's one more thing we should talk about, and I talked about it at the end of class on Thursday, but I didn't realize I hadn't posted the recording, but I did post the recording now and it should be processed. But it was a problem that said, find two fractions between 3/7 and 4/7. Okay. So find two fractions between 3/7 and 4/7. Now, if you give this problem to a kid, or maybe you, the first thing you're going to say is there's no room there, right? It's full. There's nothing between 3/7 and 4/7, right? Like there's no room. Well, let's just put it on a number line. So there's a number line. There's 0. There's 1. So if I'm going to split this into sevenths, how many lines will I draw? 6, 1 less, right? Okay, that's a huge lesson. 1, 2, 3, 4, 5, 6. So this is 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, which would make this 7/7, and this is 0/7. All right, so there's 3/7 on my number line. There's 4/7 on my number line. Boy, it sure looks like there's room in there, right? And there could always be room in there. We could just split it into smaller and smaller and smaller pieces. So who wants to tell me what is one fraction in between these two and how'd you get it?
Well, if we split each of these increments in half, then we now have 14/14. And the line in between the 3/7 and 4/7 would be, I believe, 7/14.
Yeah, it would be.
Which is also 1/2, but
Yeah, this is very similar to what David and Vanessa were doing, right? Splitting things in between things. So 6/14, 7/14, 8/14, 9/14, 10/14, 11/14, 12/14, 13/14. And I'm just using different colors so you can see, right, what I'm doing here. So now I found this value right here is in between 3/7 and 4/7. So, and like Hannah said, 7/14 is also the same as 1/2, right? So I could list 7/14 or I could list 1/2, but what if I want another fraction in between there? How can I find another one?
Can you do it by 0.25?
Oh, couldn't I just draw more lines? Yeah, I don't like discussing decimals when I'm in fraction land, right? If I'm in decimals, then we'll talk decimals. But while I'm in fractions, I want to stay in fractions. So if I just split them in half again, how big are these blue tick marks or the space between these blue tick marks?
1/4.
Are they 1/4?
28.
They're 1/28 in size. Yes. So, because if you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 27, 28. So these are 28ths now in blue. So if I count my lines here, this would be 12/28. This would be 16/28. So this must be 15/28. And this must be 13/28. So do you see how we could do this indefinitely, right? We could keep going. If we split them in half again, how big would they be?
56.
Yeah, they'd be 56ths. Notice this pattern that's going. It's going 7, 14, 28. So notice it's doubling each time because I'm taking half of it. Yeah. So that's what's happening there. So I could list the fractions 13 over 28. I could list 1/2, which is also 7 over 14, or 14 over 28. I could list 15 over 28. A lot of you have done this before, but not on a number line, right? You didn't do it visually. You did it something like this. You said, okay, find two fractions between 3/7 and 4/7. You said, well, what is this as something over 28? Well, to get here, you multiply by 4. So this is 12 over 28. And this is 16 over 28. Then you guys can see the room there. So you guys are used to doing it algorithmically instead of on a number line. Do you see how the visual is helpful in understanding? Yeah. It really reinforces the idea that it's a location on a number line. Alyssa, you all right? Okay. Boy, I got a lot of cameras off today. I don't know why, if you're just annoyed looking at me or what the deal is. You don't want me looking at you, but you should turn your cameras on or tell me why your camera is not on. I did get a message from on why your is not on. Okay. So are you ready for more? Bree is like, not quite there. Okay. All right. Think about this problem. Figure out how you would solve it. Really, really consider drawing a picture. I cannot impress that upon you so much. You made a tray of brownies for a birthday party. Okay. After the party, 3/4 of the tray is left. You eat 1/3 of the leftovers. How much of the original tray did you eat? So again, you made a tray of brownies for a birthday party. After the party, 3/4 of the tray is left. You eat 1/3 of the leftovers. How much of the original tray of brownies did you eat? I'm going to give you a couple minutes and I want to see some nice pictures. So if you have a whiteboard, it's a great idea to draw it on a whiteboard. Okay. All right. Do we have any answers? All right, Evelyn has an answer. So let's first talk operation. What operation did you do on this problem? Did you do addition, subtraction, multiplication, or division, and why?
Me or anybody?
Anyone, everybody.
Okay. I mean, I guess I already spoke, so I guess I did subtraction.
Okay.
I don't really know that much of my reasoning behind it, to be completely honest. I drew a picture
Okay.
of the original tray, the 3/4. This one is the 1/3. So for subtraction, I should have honestly added it. Now that I look at it, I think I did it wrong, but I'll still tell you what I did. So I subtracted 3/4 minus 1/3, which is equal to 9/12 minus 4/12, and I got 5/12, and that's the picture right there. But I don't think I should have subtracted it now that I'm saying it out loud.
Okay.
But
All right.
I don't know.
What do you
I
think
just
you
don't
should
know.
have done?
I think I should have added them.
Okay. Why?
Because it's what you ate. It's because it's how much you ate and how much they ate at the party. That's what I think I should have done. But I
All
don't.
right. Good. I'm glad you put it out there, Evelyn. What else? What do you guys think? Anyone do something different? Same?
Subtraction. Sorry.
You did subtraction, Sunita? Did you do the same subtraction Evelyn did?
I did 4/4 as my whole, and then I subtracted 1/4. And then from there, I did 3/4, subtracted another 1/4. And then I got a half. Pretty much.
Why did you subtract a 1/4? Oh, wait, you muted somehow.
Oh, I subtracted a 1/4 instead of a 1/3. My bad.
Did you mean to subtract a 1/4 or a 1/3? I'm just asking. I'm not judging.
A 1/4 because there was still 3/4 left. You ate 1/4. Pretty much you end up with half of tray of brownies after you ate the 1/4. Well, 1/3. I kept doing fourths instead of.
Wait, what is it? Is it a 1/3 or is it a 1/4? I'm confused.
Oh, I kept doing fourths instead of thirds, so I have to redo my math real quick.
I did the same thing. I thought it was 1/4 as well. So I was thinking they ate half of the tray as well. But then now that I'm looking at it, I'm like, oh, it's 1/3. So you actually have to make it even smaller.
Madison, do you have a question or answer?
Both, because I did a completely opposite. I mean, I did it way differently. I didn't subtract them.
What did you do?
I divided them.
You divided them. So tell me what you did.
So I was thinking of, so what I did first was I guess I'll just show it my whiteboard what I did. Can you guys see that? So I drew the 2, and then I don't know why I thought division, but I think I just read you eat 1/3 of the leftovers. So I started with 1/3 and then divided by 3/4, but then I multiplied by its reciprocal to get 2/3. But I'm just concerned because I don't think that's right now. How do you know that you subtract the fractions is my question.
I don't know. Let's talk about it. Let's keep going. Do we have any other strategies, ideas? McKenna's ready. I'm ready, McKenna.
So originally I thought the answer was 1/3 also, but now that we're all talking about it, I just tried something and I did 3/4 minus 1/3, and you have to have common denominators. So that would be changed to 9/12 minus 4/12, and then I got 5/12 would have been eaten. But I don't know if that's okay or not though, because it's a different denominator. So
I got that too.
That's what Evelyn got, and then Evelyn was debating if it was right.
I kind of liked when we were talking about division, but I did multiplication. I'm not my reasoning isn't sound, but um, trying to think about like copies of, we want like 1/3 of 3/4, and that kind of sounded like the multiplication language to me. And then that math 1/3 times 3/4, you get 3/12, which is 1/4, which is the answer I got with my picture. So
Show me your picture.
I don't know if you can see it with the.
We'll try. Sometimes you have to like, Sunita, give her some advice. How does she make it so we can see her iPad?
You have to lower your brightness a little bit and then just kind of like focus it. Give it a second on the screen.
Okay, so your original picture, yep, shows 1/4 is left, 3/4 is left. And then what does it say about your second picture?
That's the total leftovers.
Okay. And then you ate one piece out of those, right?
Yeah.
Okay. And then so your answer was, how much of the original tray did you eat, right? And so your answer was 1/4?
Yes.
Okay. Do you guys agree, disagree? What do you think? So far, let's just keep track of what's happening. I gave you a word problem. So far, we've thought we should subtract, we should add, we should multiply, and we should divide. So it's crystal clear what operation we're supposed to do on this, right? Do you see what I'm getting at here? Do you see why I posed this problem? Yeah, it's not to confuse you or to make you cry. It's to show you that sometimes we have a challenge of what are these words telling us, okay? So before I show you my solution, let's talk. We can visually see how much we ate if we draw a picture, right, Hannah? You can visually see how much you ate, and she ate 1/4 looking at her picture of the original tray of brownies. But what operation are we doing when we're solving? We're unsure, right? We're not clear why we're getting that. So, but I'll show you my picture. So here's the pan of brownies, right? I'm going to break it into 4 pieces and shade one piece because that's what was eaten at the party. Okay. So first of all, if you're doing the Poya 4-step method with this problem, the first thing you should know when you're doing understand the problem is your brownies are bad. Let's face it. No one brings a pan of brownies to a party and brings home 3/4 of a pan. I'm just saying, right? So that's another reason I gave you this problem. Did anyone even think of that when they read the problem? Yeah, McKenna did. Bree did. A couple of you did, but some of you are like, no, I just looked at the numbers and tried to pull it out. When you do this in a classroom, that's exactly what kids will say. The kids will be like, wait, there were brownies left? The brownies should be gone, right, from the party. And then the second thing is when you get home, you eat 1/3 of the leftovers. So apparently you like your brownies, right? Nobody else might like your brownies, but you sure do. So here's my, notice that I kept my unit the same size. Does everybody see that? And when I looked at some of your pictures, like Evelyn's, Hannah's, and so on, like your unit changed size. So be careful, right? That's why I kept my original pan of brownies to be my full unit, because the answer said, how much of the original pan did I eat? So I knew my original pan was my full unit. So now I ate 1/3 of these pieces. Conveniently, this was already broken into 3 pieces. Did you see it? Because one of the pieces is gone. So I ate 1/3 of the leftovers. But that 1/3 of the leftovers is 1/4 of the original pan. Exactly what Hannah was saying, right? So, but when you did subtraction, or when you did division, you didn't end up with 1/4 as your answer. We just got our answer visually. So let's look at our operations. If we did addition, we wouldn't get the right answer because if you notice, we would get more than 1. If we did subtraction, we know that can't be the right answer because we got 5/12. It is actually multiplication. And that's what Hannah was kind of getting at when Hannah said, that sounds like the copies of statement, right? 1/3 of 3/4. Did anyone have a teacher that told you that that word of means multiplication? Did anyone have a teacher that said that? Yeah, some of you did. And I'm not sure I love that statement because I'm not sure it always means it, but I would say that it means it a lot. So I'm not against that. And it's not division. So it's really tricky when you get a word problem. And this is what kids say because teachers do lessons at a time. Today we're doing adding fractions. Tomorrow we're going to subtract fractions. Next week we're going to multiply fractions. Next week we're going to divide fractions. If I would have at the top of this paper, which by the way, I've seen teachers do this before, multiplying fractions is the header on this top of this paper. Do you think kids will struggle as much? No, because some kid's going to read that it says multiplying fractions, but don't give it away. Don't give them those contextual clues of titling the section. Make them think it through. So it really is a multiplication problem. Tricky? Did this remind you of any problem that you did on your rational number homework? How about Jill's chocolate bar? You remember Jill's chocolate bar? Yeah. Jill and Jim, I can't remember if his name was Jim. I feel like it was a J name. Were supposed to share a chocolate bar, right? And the guy, he was supposed to get 1/4 of the original bar, but Jill only got 3/4. Thanks, Jessica. Jill and James, see, it was a J name. Okay, so Jill only got 3/4 of the bar. And so James is going to have to get his chocolate from what Jill has. So he's only going to get 1/3 of Jill's bar. But that's really 1/4 of the original bar. So do you see how fractions all are relative to what the unit is? What unit are you talking about? So if somebody walks up to you and says, do you want half? You better say of what? Because they could say half of the garbage in my house or half of the debt, right? I have. So be careful. Fractions are very relative. So I love the brownie problem. It's one you could do with a piece of paper as well, right? You could do it with just a sheet of paper and fold it, and you'll see that pan of brownies works out very nicely. Okay. So sometimes word problems are difficult to decipher which operation makes sense. Do not underestimate the power of drawing pictures to model the mathematical situation. Like Hannah said, she's like, my picture was right, but I'm not sure why it's multiplication. That's fine. Your picture was right. If you can justify it with your picture, that's MP4, model with mathematics, right? More power to you. Okay, now let's do a little reflection back to whole number multiplication. Remember when we were in whole numbers, the first factor was the number of groups or copies, and the second number was the size of the copy. So the same is true when we're doing multiplication of fractions. So 4 copies, 4 times 3 is 4 copies of 3, which would be a total of 12 for all copies. So we're good so far. Now look at this. We can multiply with pictures. I know you can handle it. I promise. You can multiply fractions with pictures. You really can. So if that rectangle is our unit, we want to show 2/3. Well, we would just draw, maybe. We're going to say those two are exactly the same size, by the way. We would show 2/3 like this. And then if I was going to do 6 copies of 2/3 or 6 times 2/3, I'm going to do 6 copies that look like this. Now, I know it's tedious, and these are all exactly the same size. You can't tell, but they really are. They're all exactly the same size. It's Zoom that's distorting the image. It's not me. That's a lie. Okay, 1, 2, 3, 4, 5, 6. Okay, so do you agree that I just drew 6 copies of 2/3? Everybody with me? I drew 6 copies of 2/3. Can we figure out how much we have here? Okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 12 1/3 size pieces. Do you agree? I have 12 1/3 size pieces. So I have 12 1/3, 12 1/3 size pieces. So I could say I have 12 thirds now, right? So if I do 6 times 2/3, I get 12 thirds. Now, some of you don't like 12 thirds. It's bothering you a lot. I get it. I appreciate you. It's okay. This is also how you can see, where would I get if I was just looking at this multiplication sentence? I don't know anything about multiplying fractions, but if I just look at it, can anyone see where I might have gotten the number 12 from with those numbers? Yeah, what might I have done? How could I get a 12 using those numbers, 6 and 2/3?
6 times 2.
Yeah, I could multiply the whole number times the numerator, right? And I would get 6 times 2 is 12. And then the denominator just stayed there. Well, I could also rearrange these. I could say, okay, let's take this third and put it right here. Now I have one whole. And then I could take this third and put it right here. Now I have another whole. I could take this third and put it right here. Now I have another whole. And then I could take this last one and put it right here and get another one. And then a lot of you are like, yeah, because your answer's actually 4. Right? But 12 thirds is fine. I can see it in my picture. And then I can rearrange my picture so I can get that whole 4. So pictures work, even in fractions. Okay, and there I have it nice right here. Here's some standards you have in 4th grade. We've talked a little bit. Do you see it says apply and extend previous understandings of multiplication to multiply a fraction by a whole number? And then understand a fraction a over b as a multiple of 1 over b. For example, use a visual fraction to represent 5/4 as the product of 5 times 1/4, recording the conclusion by the equation 5/4 equals 5 times 1/4. That's just what we were doing. And it connects to this last one. Understand a multiple of a over b as a multiple of 1 over b, and use this understanding to multiply a fraction by a whole number. For example, use a visual model to express 3 times 2/5 as 6 times 1/5, which means it's 6/5. These are the standards. I didn't make them up. The standards don't say teach them an algorithm for multiplication. The standards say, do they understand what's happening, right, with this multiplication? So, and these really are our standards, by the way, in case you think I'm making it up. I promise you I'm not. Okay. Let's look at this one. Can you draw it with a picture? Joe's very picky about pizza. He asks for pepperoni to be on half of the pizza and mushrooms on, listen carefully, 3/4 of the pepperoni side. What portion of the entire pizza has both pepperoni and mushrooms? So he asks for pepperoni to be on half the pizza and mushrooms to be on 3/4 of the pepperoni side. What portion of the entire pizza has both pepperoni and mushrooms? Solve it using a picture, please. And then we'll share our pictures. And you can draw a circle for a pizza. I did. You don't have to. It could be a rectangular pizza. Everybody doing okay? Anyone need 30 more seconds? Okay. Anyone stuck? They don't know where to start. Hannah, spoiler alert. Hannah gave her answer. But you don't have to look at the chat if you don't want to. All right. Who's going to share their picture? Oh, I see a picture by Evelyn. Sunita, you can hold yours up too. I can see both of them. All right. So we have different answers. We have 1/4 from Sunita. We had 1/4 from Hannah. Evelyn, well, your answer was 3/8. Betty got 3/8, right? Did anyone, so what's the answer? Is it 3/4? I mean, is it 1/4 or 3/8?
Well, I could explain my reasoning for why I got 3/8. Okay, so it says half, okay, I'll show it. So half of the pizza has pepperoni. The circles are pepperonis, the lines are mushrooms, okay? Like the small lines. So that means exactly half of it will have pepperoni. So you draw a line for half. 3/4 of the pepperoni size has mushrooms. And so that just makes me assume that there's 8 slices for the whole pizza, because since there has to be at least 4 slices on the half side of the pizza that has pepperoni. And so I drew the pepperonis on half of the pizza, and then I did the mushrooms, and it got me with the whole pizza 8 slices, and 3/8 of the slices have pepperoni and mushrooms. So that's my logic.
Nice, Evelyn. Does anyone agree with Evelyn? Is there anyone who likes the 1/4, who thinks the 1/4 is the answer? Sunita? Karina, are you 1/4? And Hannah, are you still 1/4? Okay, so let's read it again and look at your picture and make sure it matches this. He asked for pepperoni to be on half of the pizza. Do you have pepperoni on half of your pizza? Okay, now listen carefully. Do you have mushrooms on 3/4 of the pepperoni side? Do you have mushrooms on 3/4 of the pepperoni side? Sunita, Karina, Karen saying she says it now. Hannah, do you, oh, so again, it's a reading comprehension issue. It is not a mathematics issue, right? Believe it or not, reading is one of the biggest downfalls in mathematics. If you have a kid who's struggling reading, they are going to struggle in math. Okay. So if you have a kid that's really low in reading comprehension, you might notice that they really struggle in math, and it's not necessarily a math issue. So, but Hannah, the answer is not 1/4. The answer is 3/8. Here is my picture. It's a multiplication problem. Yes?
The 1/4 would be just pepperoni, correct? Because the other 3/4 are pepperoni and mushroom.
Wait, the piece that's, the question was, what portion of the entire pizza has both?
I'm just trying to reiterate like what their 1/4 would be. That essentially is probably what they meant, right?
I don't know what 1/4 would be. 1/4 would be nothing as far as I can see, because I have half the pizza that's cheese, right?
Yes.
And I have 1/8 of the pizza that's pepperoni only.
1/8. Okay, got it.
right? Hannah, are you okay? Ah, it's because you put the mushrooms on the other half. But doesn't it say it has to be on the part with the pepperoni? Yeah. So you have to read it really carefully. Questions on this? Okay. Look at this. Multiplying fractions on a number line just when you thought it couldn't get better. Yeah, it has right here. Multiplying on a number line. So 5 times 1/3 would be 5 copies of 1/3. You could do it with rectangles. I have no doubt you could do it with rectangles. I already did one with rectangles. But can you do it on a number line? So I have a picture of it on a number line, but I can do it live, okay? Because I think that might help. We want to do 5 copies of 1/3, okay? So let's do 5 copies of 1/3. Let's do whiteboard. Okay. So here's my number line. Here's 0 on my number line. So I want to show 1/3. Yes? So I'm just going to go, okay, this amount right here is going to be 1/3. So there's 1 copy of 1/3. Well, I need 5 copies because I'm doing 5 times 1/3, which is 5 copies of 1/3. So there's 1 copy. If I do, oh, that seemed a little large. Okay. If I do another copy, then I'll be at 2/3. Do you agree? If I do another copy, I'll be at 3/3 because I'm on a number line here, right? And then I'm going to do another copy. So now I'm at 4/3. And I'm going to do one more copy. And I'm at 5/3. So 5 copies of 1/3 must be 5/3. You agree? I could draw my number line first and go, okay, if I'm going to go 0 to, let's say, 2, and I know I'm counting by thirds, then I don't know my answer yet. Oops, that's a 0, that's a 1. But I'm just going to put all these thirds in, and I'm going to number them all, label them all. And then I'm just going to count. There's 1, 2, 3, 4, 5 copies. I end up at 5/3. Nice. Isn't it pretty? Number lines are so fun. They're not all that beautiful, right? Sometimes we have trouble. Sometimes they're a little more troubling than this. I have a Jamboard where you're going to kind of work your way through this. So if you did it like this, oh wait, I'm not sure I'm sharing this one. Hold on. Let me share this. I'm going to let you work on a Jamboard in just a minute to kind of make sense of this. Let me get here. Because I did kind of an easy one. What if I do one like this? 1/3 times 1/4. Now, I know you know the answer, right? Because I know you already know how to multiply fractions, but let's make sense of it on a number line. What's my copies of sentence for this? When I do this, ignore my answer for a minute. What's my copies of sentence?
We need 1/3 copies of 1/4.
Very nice. 1/3 copies of 1/4. Well, so if I want to take 1/3 of a copy of 1/4, I better know what 1/4 looks like first, right? So if I have this to be 0, and I'll just say this is 1, I don't know why I have these tick marks here. Like I just made them up. So we'll just label them like this. So first I want to show 1/4. So to do 1/4, there's 1/4 right here. Yeah. So here's 1/4 right here. From here to here is 1/4. Do you agree? Okay, now I want to do 1/3 of a copy. That means I need to split this 1/3 into 3 more pieces, right? So I could take just one of those pieces. So I'm going to split this into 3 pieces. And so I want 1/3 of, that's 1/3 of 1/4 from here to here. This is the part I want. That's not 1/3, that's 1/3 of 1/4. So where would 1/3 of 1/4 be? Well, picture this number line with all the same tick marks. And it's easier if you get to 1. So you go, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there, if this little section must be 1/12. Because I took 1/3 of the 1/4. Do you see how it's similar to what we were doing on our Jamboard, splitting things into more pieces? Yeah. Okay. So before I let you go on that Jamboard, because I don't want you guys to freak out. This is your list of all your assignments for the week, right? So no crying. Okay, no crying. Let's start here. Let's decipher this. So this is a video assignment. Those are usually pretty doable, right? This is a video assignment. This is a video assignment. So far the 3 assignments are pretty short, right? Our video assignments are usually pretty short. Okay. This assignment right here, we're doing in class. You don't have to turn in anything. Okay. No turning in anything for that assignment. This one you are going to turn in. So I better get rid of the ones we're not going to turn in. So this assignment right here, we're going to do that one in class. We're doing that tomorrow in class, that division assignment. Okay. These are just more assignments. You can work on those anytime you want. MOER, MOER, you can work on those anytime. This assignment will either start in class or do the whole thing in class. Okay. So what that means is the ones you really need to worry are these 2 more assignments. You definitely need to do the video assignments, but they're short, right? And then this flip grid assignment. Okay. Those are the ones you're going to have to get started on right away. Okay. Does that make you feel a little bit better? I know there's still a lot of them, but that should put it more into perspective. Okay. So I'm going to have you work for about, I don't know, 10 minutes or so on this flip grid and just see how far you get. You're in bigger teams. You're in like partner pair teams. So you're in with like 4 people. So it should be more helpful. And again, if you share the Jamboard with everybody, it's easier to write on, but however you decide to do it, if you want to just write on paper, that's totally fine. Okay. So questions on what we're doing right now? Oh my gosh, I can't get the Jamboard copied. My screen is going bananas. Okay, here we go. So you won't be able to write on this one. You'll have to make a copy of it. You can make your own copy. You can make a team copy. I don't care. Okay. And then I'm going to put you in your breakout rooms. You should be with a bigger group. And then I'll come in. I should be able to visit all of you. Hello, hello. You're all back. I know you didn't have a chance to get through that whole thing, and I know you were super excited to, right? There was so much more you could work on. Here's the good news. You can work on that Jamboard anytime you want in your spare time. I know you have so much of it around, right? Just kidding. But I will, if you want to work with me on any of that stuff, you totally can. If you just want to screenshot a part of it and say, are we on the right track? What's happening here? You can work your way through it. You can always go through my slides. I can post my Jamboard key whenever you want, you know, if you want to email me and say, hey, can you send me your Jamboard key? But I highly, highly, highly do not think it's a good idea for you to ask for the key before you've worked your way through it. Because just looking at my key is not the productive struggle that you need, right? You need to be thinking through it first before you look at someone's key. I don't know if you've done that before, but it's a bad move to look at a key before you've actually gone through it. You can do the area model. Do you remember the area model? You guys all loved it for multiplication of whole numbers. Here it is for fractions. You can totally see it. 1/3. So you can see our thirds are here. Right, here's our thirds and here's our fourths. And so the area of overlap is actually the solution. So 1/12. You can also do this with paper folding. It's a great strategy. Switching numerators. This isn't something I ever ask you to do, but it's just kind of fascinating to me, maybe not to you. Okay. Mixed numbers. How do we multiply mixed numbers? Notice I have this all worked out here. So you can review this anytime you want. Now, fraction multiplication with pattern blocks. This will make some of you cry. Okay. But that is not my intention. My intention is for you to retrain your brain to see these pattern blocks in a new way. Notice, look, I have my answers right there for you. Okay. So this is part of your visual fraction multiplication assignment that's due. I've done some of it right here. I've done the first 2 problems for you. Okay. And then I've done it with rectangles. So I think there's only like 4 problems I haven't done, but they're in the slides. So make sure you look through them. Okay. See, we made it. I know you have a lot to do, but let me put the exit ticket in the chat. The exit ticket should be super duper quick. So it shouldn't take you a long, long time to do that. Please, please, please come see me if you're starting to get stressed out about the final exam or what we have left, or if you need help with anything. Okay. And I'm going to put that in the chat right there for you. And then have a great day. I will stick around if you need anything. And please send me your questions or come meet with me. Happy Monday.
Happy Monday.
Yes, happy Monday. Yes, Jessica, we have class every day. Bye, Vanessa.
Hi, I don't know how good like my internet is, how you can hear me.
I can hear you.